In 3D, we won't do the derivation, but in 3D, in Cartesian coordinates, and I just write that to distinguish that. You could also write this equation in polar coordinates or some other coordinate system, but in Cartesian coordinates, then we have so the right-hand side is the same. The left-hand side now, you just have this extra term that includes the fact that the velocity is now, in 3D, the velocity is a vector, right? And so if we write this compactly, using notation from vector calculus, we have that the divergence of the density times the velocity vector is equal to the same right-hand side. So does everybody remember that this divergence operator? Does it scare you? So just like if I, just as an aside, if I have a vector A and it's equal to, has components A1, A2, A3, and then I have a vector B that has components B1, B2, B3, then the dot product A dot B, right, is A1, B1 plus A2, B2 plus A3, B3, right? So just, there's really nothing different than that except this del is now an operator, and it's an operator that looks like this. So it has partial x1, partial, in Cartesian coordinates, x, y, z. So these are separate components, right? And so then I have u is equal to ux, uy, uz. So then I just take the dot product of the gradient operator with the vector u. It's like that. So, it's useful to sort of just, anytime you have vector operations like the gradient and other things, is you're dealing with vectors or second-order tensors or whatever, it's always useful to just look at both sides of the equation or look at every term in the equation and make sure that they make sense, right? So if you take u as a vector, right? If you take the gradient of a vector, what do you get? You go up one order, so it'd be like a tensor or a matrix, right? So if you take the divergence of something, you go down one order because it's like taking a dot product, right? So if I take the gradient of a vector, the gradient of a scalar, I have a vector. If I take the divergence of a vector, I have a scalar, right? So here I'm taking the divergence of a vector, I have a scalar, and then on the right-hand side I have a scalar. Right? Every term is a scalar. So whenever you're dealing with these vector operations, it's just useful to always check every term and make sure it is what you think it is. If it's supposed to be a vector, make sure it's a vector. If it's supposed to be a scalar, make sure it's a scalar.